Hi, this is Mrs. Polgar, and we will be discussing energy in ecosystems today. So, a couple classes ago, we were talking about the characteristics of life. I tried to trick you with a candle flame. I told you it was my best friend Luca and that it was very much alive, and you had to prove to me that Luca was not alive. And eventually, we looked past some features like the fact that the candle flickers and then it's cool and then it's very bright. And we came up with a list of rules that all living things have to follow. And we realized that Luca did not, in fact, have things like cellular organization or heredity. And we decided that the candle flame was not actually alive. However, we are very much alive and we basically have all 8 of these characteristics. And one of those characteristics is the characteristic of the day, which is energy processing. So we will be talking about energy in this lesson and for the next few lessons going forward. All living systems rely on a constant source of energy. Even if you're sitting there really bored, sick out of your mind, doing absolutely nothing, you are burning through energy. Your brain is burning through energy. Your heart is beating. You are controlling things inside of your body that require this constant source of energy. The primary source of energy for life on Earth is the sun. Now, in a nutshell, this is how energy flow happens. Plants take that energy from the sun and they transform it into chemical energy, which is stored in the chemical bonds of sugar, right? Plants make sugar. And how do they make sugar? They make it through the process known as photosynthesis. Other organisms that can't make their own food, and plants actually do this as well, they release the energy found in sugar. They take that chemical energy and they release it. And they release it through a process known as cellular respiration. Now, the energy that's released through cellular respiration can be used to do work, whether that means walking around or thinking or sending messages throughout your body. All of those require energy. Eventually, after you've done this work, all of that energy is lost as heat, and it basically is lost to the universe forever. Autotrophs and producers. Organisms that obtain energy from sunlight or chemicals are known as autotrophs. Auto, that word part actually means self, and troph means to nourish. So autotrophs can actually nourish themselves. They can make their own food. Since they produce their own food, they are also called producers. Plants produce food through photosynthesis. Not only plants can perform photosynthesis, some bacteria can do that as well, and some protists. So you have a picture here with photosynthetic bacteria, and you can see the chloroplast inside of that bacteria. Now, that's not the only way autotrophs can work. We have things known as chemoautotrophs, which you can see on the right-hand side, and they obtain energy from inorganic chemicals. Chemosynthesis is the process they use, not photosynthesis, and they basically form carbohydrates using chemicals as an energy source. And some bacteria live in these very extreme places, like inside of volcanoes or deep sea vents, and they perform chemosynthesis. Heterotrophs. Heterotrophs are organisms that need to consume other organisms for food. And hetero, in this case, the word part means different. Heterotrophs are also referred to as consumers, and those terms are used interchangeably. You can see the lions and the lemur, they are both consumers. There are different types of heterotrophs. Herbivores are one type. Herbivores obtain their energy by eating only plants. If you have a vegan friend, you're friends with an herbivore. The rest of us, we are all omnivores. We eat both plants and animals because you probably want to eat some steak with your potatoes. Carnivores, like your cat, for example, eat only animals. They do not eat vegetables. And then decomposers break down organic matter and basically return it to the environment. Trophic levels. Trophic level is a level of nourishment in a food chain. So energy in an ecosystem flows like this. It goes in one direction. It begins with the sun. It's taken up by the producers. The producers are then eaten by the consumers and they get the energy, and eventually energy is taken up by decomposers. So energy flows in one direction. Each step in this transfer of energy is a trophic level. Food chains. Food chains show how energy flows from one trophic level to the next. So you can see on this picture, we have energy going from the plant to the herbivore, to the carnivore, to the other carnivore, and to that top level carnivore. The first level is known as the producers, in this case the plant. The second level is the herbivore, in this case it's a grasshopper. Sometimes herbivores are called primary consumers because they are the first thing in the food chain to actually consume or eat, because the plant's not actually eating. The third level, in this case that rodent, is a secondary consumer. It's a carnivore. It's the second thing in the food chain to eat. That's why we call it a secondary consumer. The fourth level is another carnivore. In this case, it's the snake. And we call that snake a tertiary consumer because it's the third animal on this food chain to actually eat. The first was the grasshopper, the second was the rodent, and the snake is the third, the tertiary consumer. And each step is a trophic level. Omnivores are organisms that eat both plants and animals. They can be listed at different levels. Here you can see another food chain, one that's in the ocean. Food webs. Food web is a complicated, interconnected group of food chains because life is not that simple. A food chain only shows you one path of energy, but ecosystems are a lot more complicated. You are more complicated. You don't just eat one thing, right? You eat lots of different things. Most animals eat lots of different things. They're eaten by a lot of different things. So food chains are too simple to really give enough information about an ecosystem, and that's where food webs come into play. Arrows on a food web and a food chain actually show you the flow of energy. So the arrows always point to where the food is going, where the energy is going. They always start with the producers and they go upwards to each level. Loss of energy. Turns out that this process is actually super inefficient. Energy is lost at each trophic level. Energy is lost each step of the way. In fact, 90% of the energy is lost every time you jump to the next trophic level. So on this diagram, you can see we start off with 1,000 units of energy. The producers have this energy, right? They've got all this energy. They feel awesome. They're growing. They're making seeds. They're doing all these things. However, in their life processes, they use up a lot of that energy. And by the time the grasshoppers eat the producers, there's only 100 units of energy left for them. 90% was lost. As you move up the chain from grasshoppers to frogs, again, 90% of the energy is lost really to do work, and it's eventually lost as heat. And by the time you get to the frog, you have 10 units of energy. At the very top, we're left with only 1 unit of energy. Pyramid models. Okay? Pyramids turn out to be a really good way of organizing what happens to energy and biomass in ecosystems. So this is an energy pyramid. It shows the loss of energy in an ecosystem. Each layer represents one trophic level, and organisms at the top are rare because more energy is required to support them. So again, we start off with the grass. It has 100% of the energy. However, 90% of that energy is going to be used up to do work, and it's eventually going to be turned into heat and leave the planet. By the time the insect eats the grass, it's only working with 10% of that energy. By the time the rodent is eating the insect, it's got 1% of that energy that's left, because 90% is lost again as heat. And by the time we get to the top, which is the hawk, 0.1% of all that energy is left. The rest of the energy has been used up as heat. Biomass pyramid. A biomass pyramid compares the biomass of different trophic levels. Most of the biomass in an ecosystem is on the bottom, which means you have the most producers. in any given ecosystem. That's where most of the mass is. So you can see on the diagram on the right, you have producers on the bottom. We get to the primary consumers, which are these little fish, and you can see there's less of them. There's less of them in grams per meter squared. And the larger fish, we have even less, 150 grams per meter squared. And we get to the top with the humans, we have 75 grams per meter squared. On the left is another biomass pyramid. You can see we have grass on the bottom. Then snowshoe hares, we have less biomass in that step. Red fox with the wolf at the very top. So at any given time, if you have a top level predator, an apex predator, there's very few of those predators going around because an environment can only support few of them. So this has been basically an introduction to energy and energy pyramids and ecosystems. I hope that was helpful.